In this video, I'll talk about the things that you need to know about systems of equations and systems of inequalities for your final. First question, do the systems of equations below have the same solution? So we have two systems of equations. Number one, x plus y equals 15 and 2x minus 7 equals 12. So that is one system because the system is two equations. Okay. Number two, 3x plus 3y equals 15 and 2x minus 7 equals 12. So that's another system. These two go together. Okay. In order for these two systems to have the same solution, they need to be equivalent equations because I see that 2x minus 7 equals 12 is right here in the first choice, and 2x minus 7 equals 12 is there in the second choice. So if one of the equations is the same, the other equation would also have to be the same for them to have the same solution. So let's see. Can we say that x plus y equals 15? So this equation over here is equivalent to 3x plus 3y equals 15? Let's think about this. If we want to go from x plus y equals 15 and try to get an equivalent equation, let's see what happens if we multiply all the way across by 3. I'm choosing 3 because over here we have 3 in front of x, and I know if I multiply 3 times x, I'll have 3x for this equation as well. So let me multiply all the way across and see if I get the same equation that I have in the second system, the 3x plus 3y equals 15. So I did 3 times x so far, and that was 3x. Then I'll do 3 times y, and that's 3y. And then I'll do 3 times 15, and that is 45. So I see that I did not get the same equation that I have in the second system, because the second system says 3x plus 3y equals 15, not 45. So if one of the equations is the same, but the other equation is not the same, then the answer is no. These two systems of equations do not have the same solution. Let me try another problem like this. Okay, same question. Do the systems of equations below have the same solution? First system is 2x minus y equals 1 and x plus 4y equals 18. Second system, 2x minus y equals 1 and negative 2x minus 8y equals negative 16. So again, we see one equation that's the same. And we want to see if the second one is also the same. So I'm going to do the same thing I did before. I'm going to say I'm trying to see if I could get this thing to be equal to this thing. This has a coefficient of negative 2, so I'll multiply this thing across by negative 2. Negative 2 times x is negative 2x. Negative 2 times 4y, negative 8y. Negative 2 times 8 is negative 16. And look what I got, the exact same equation that I have in the second system. So since that second equation is equivalent to the second equation in the other system, and the first equation is exactly the same, these two systems are the exact same two equations, the exact same two lines on a graph, so they will meet at the exact same point. So the answer is yes. These two systems do have the same solution. Now let's move on to a system of inequalities. Okay, this is a system of inequalities. It's already graphed for you. The first one is y is less than or equal to x plus 4. The second one is 3y is greater than 4x plus 12. We don't really have to know the inequalities. We see the whole graph there. Okay, and the question is, determine whether each of the following points is a solution to the system of inequalities graph below, and explain. Explaining is important. I will ask you to explain a similar question to this on the final, so make sure you're able to explain each possibility. I use negative 2, 3, negative 3, 0, and negative 2, 6 because these 3 points represent different things on this graph. So first we have negative 2, 3. Okay, negative 2, 3 is the point right over here. Okay, that's negative 2, 3. Is negative 2, 3 a solution to the system? Well, in order for it to be a solution to the system, it has to be in the part of the graph that's shaded for both lines, for both inequalities. And look, it's right in between where it's shaded in red and it's also shaded in blue, right? It's shaded for that solid line. It's also shaded for the dashed line. So the answer is yes, this is a solution. Okay, it's part of the region that represents the solutions to both inequalities. So yes, it is, and we have to explain because it is in the region. Okay, so the section of the graph that is shaded for both inequalities. So that means that it makes a true statement if you put it into both of those inequalities. Okay, the next point we have is negative 3, 0. Negative 3, 0 is right over here on the x-axis and on that red dotted line. Is negative 3, 0 a solution? Well, let's see. Is it in the shaded region for the blue line? Yes, it definitely is. It definitely is a solution for the blue inequality, y is less than or equal to negative x plus 4. What about the red? Well, it's on the line. Are the points on a line the solution to an inequality? Well, if the line is dashed, as it is in this case, then no, the points on the line are not solutions. They're not included in the solution set, okay? It says 3y is greater than, not equal to. So you'll get the same number on both sides of that inequality if you take a value on the line, but that's not true because it'll say the same number is greater than itself, which is not true. It's only true if it has the equal sign. If it's a solid line, then it's included. Here it's a dashed line, no equal sign. No, the point on the dashed line is not included. So the answer is no. Negative 3, 0 is not a solution, okay? It is a solution to one inequality, but not both, because it's on the dashed line. So you could write something like, it's in the shaded region for one, so it solves one. It's on the dashed line for the other, so it doesn't solve that one, okay? However, I just chose to write it this way. There are other ways you can express it, but that is why it's a solution to the blue and not to the red. Lastly, we have the point negative 2, 6. Okay, where's negative 2, 6? I see negative 2 on my x-axis, I see 6 on my y-axis, and that comes out exactly on that line. So once again, we have a point on a line. So let's see, here we see it definitely is in the shaded region for the red, right? But it's on the line for the blue. But this line is different than the previous point, that purple point, right? Because here we have a solid line. When it's a solid line, it means there was an equal sign in that inequality, and the points on the line are part of the solution set. So the answer is yes. This time the point is a solution because it's in the shaded region for one inequality, and on a solid line for the other inequality. So therefore, it is a solution to both inequalities. So make sure you're clear on all of these three different possibilities. You can go back and watch the video and watch my explanation again, because you are going to have to answer one question like this with one of these three possibilities and give me the explanation.